Hey guys, here's the review backup video, and this is going to be something that if you don't like the way things are explained, you might take a look at. I don't know that I'll get the entire thing done, but I'll do my best. For the first problem, we're dealing with RAM and integrals as area. The big idea is that if we have some kind of an integral from a to b of f of x, or in this case, since we have a derivative, let's call this f prime of x, that's equal to the value separated, which is the same thing as the area under the curve from A to B. Okay, so now let's look at the problem. So we got f prime, which is this lovely line here. We know that f of 0 is 5. So that's a starting value. And f of 1 is what we want to figure out. So we know that the function should be 5 at this point. And if in terms of this derivative, we're starting at 5 and we're adding this accumulated area to this 5, we should be able to figure out what that value change should be. So here we've got a 1 by 6 triangle, which means this has an area of 3. 5 plus 3 is going to be 8. If you want to do this all algebra, you could say this is something like, okay, so we're going from the integral from 0 to 1 of f prime of x dx. That tells us that we're looking at that area. So 3 is equal to f of 1, that's what we're looking for, minus f of 0, which we're told is 5. Some number minus 5 is equal to 3. That number has to be 8. Either way of thinking about this is totally fine. Alright, so for number, this doesn't have a number, I guess. We're doing a trapezoidal approximation. And in this really small graph, what you can't see so well, this is x squared. This is going to be a super pleasant thing with fractions, because we've also got 4/3 and 5/3 to work with. I'm going to make a table just to kind of make my life a little bit easier. I don't know why I made the... This is the world's least balanced table. So we've got x values and y values. I'm going to call these 1, 2, 4/3, and 5/3. For squared, that would be 1. That would be 16 over 9. That would be 25 over 9. And that would be 4. For the trapezoidal, excuse me, for trapezoidal approximation, we've got to make 3 trapezoids, and they're all going to be based on the idea that the area is 1/2 b1 plus b2. Those are our bases. And here, those are our heights, and then times some kind of height. And here, that's our width of each interval. In this case, all of the widths are going to be 1/3 because we're increasing by 1/3 each time. Okay, so for trap 1, we've got 1/2. Going to move that 1/3 out front in the back. And then that's going to be 1 plus 16 over 9. For trap 2, we've got 1/2 times 1/3. And then that's going to be 16 over 9 plus 25 over 9. And then for trap 3, we're going to 1/2 times 1/3 times 25 over 9 plus 4. This is a really pleasant looking problem. Okay, so that would be a 1/6. And then 9 over 9 plus 16 over 9 is 25 over 9. I'd have a 1/6. 16 plus 25 is 41 over 9. And then for the last one, I've had a 1/6. And 25 plus 36 is going to be 56/61 over 9. Okay, bottom's going to be 54. And then we've got 25 plus 41 is going to be 65 plus 60 is going to be 125 plus 1 is 126. This can reduce by 2, 27, and 63. That can reduce by 9, and that's going to be 7 over 3, which is C. Next up, we've got some integral props and FTC. The first one, we got to do some integration. Big idea here, k is a constant. That means, for example, when we find the antiderivative of 2kx, that would be 2kx squared divided by 2. The k is just a constant. We're going to figure out what it is in a minute. Those 2's cancel out, by the way. And then minus x squared, so that's going to be x cubed, and then divided by 3. So if this equals, going from k to 0, that equals 18. Let's plug k in. So we got k times x squared with k squared would be k cubed, plus negative k cubed over 3, and that equals 18. Plugging 0 in for the bottom cancels both of those out. I guess let's multiply everything by 3 just to get rid of that. So 3k cubed minus k cubed is equal to 18. When we subtract these, we get 2k cubed is equal to 18. Dividing by 2, k is equal to, k cubed is equal to 9. And I noticed I did some math wrong by ignoring multiplying by 3 here. This should be 54, which makes this also 54, which makes this 27, which means that the cube root of 27 is 3. Oof, I got worried for a second there. All right, for the next one, which does not go with a graph, that's for the one down below, we've got the integral from 1 to 10 is 4. The integral from 10 to 3, I'm going to rewrite that as 3 to 10. And I know that if I flip the bounds, that makes this negative. Okay, that's probably a big deal. I'm looking for 1 to 3. Big idea here. The integral from 1 to 3 of f of x plus the integral from 3 to 10 of f of x is the same as the integral from 1 to 10 of f of x. Lovely handwriting there. It seems like we're having some connections here. So, okay, so we've got 1 to 10. So 4. We've got, we don't have 1 to 3, so I'm going to call that question mark. That's what we're looking for. And then we just figured out that, wow, in even worse writing, this looks like a -1 now. It should be a -7. So question mark plus -7 is equal to 4. That question mark has to be 11 to make that true. All right, the last of these, we've got some kind of, I guess we got one more down below. We've got some kind of a graph. It says that h of x is the antiderivative of f. And that's going to ask us to do some different things here. Okay, so h of x, the h of 6, this means area between 0 and 6. And in this case, that's going to be negative. All right. H prime of 6 is the same as the derivative of this thing, which is just going to be f of 6. So if the h is the antiderivative, that means if I take the derivative of h, I get f. F of 6 is 0. These are actually kind of cool problems because they don't require a lot of math, but they require some clever thinking. I like that. H double prime of 6 is the same as the derivative of the derivative. Okay, so that would be f prime of 6. That's slope. And at 6, the slope is positive. So therefore, we're looking at something where we have things that are less than 0, equal 0, or greater than 0. Each double prime would have to be the biggest. Okay, so that eliminates that one, and that one. The middleist would have to be h prime. So that leaves us with a, and we're good to go. For number unknown, we've got big F of x is an antiderivative of this thing. We've got f of 1. We were trying to find f of 9. This is definitely going to be a calculator one. And what I need to see is the setup. So you're looking from 1 to 9. And we're starting at 0. So that's f of 1 is equal to 0. And when I start this, so we got starting value. This is the change, the accumulated area. And we're going to end up with the final value of f of 9. And the integral of this would end up being ln of x to the third over x. So two things are going on here. First, that you can totally use u sub to solve this. The second, I noticed these answers were all decimals. That means it's calculator active. I'm definitely going to use fnint to solve this problem because it's a lot faster and a lot less problematic. So if you do that, you don't have to show me that you've done that, but I do need to see this step, or at least this, in order to give you any credit for this problem. So math, fnint, and what we're really doing is just putting this into that problem. Be careful to have ln of x inside the parentheses and the cubed outside of it. Otherwise, it's going to spit out an answer. I don't have a calculator on me, so I don't know which one of these is actually the right answer. But I'm sure that you guys can figure that out. I have faith in you. Or watch Mr. Butterworth's video that also goes through this. Alright, next up we've got some u substitution. In this case I see 3x is inside the function, so I'm going to make u equal to 3x. That means that du dx is going to be 3, and dx is going to be du over 3. When I go to plug this in, we got the antiderivative of cosine of u du over 3. I'm going to move that over 3 out front. This will be 1/3 cosine of u du. Okay, so the antiderivative of cosine we know is going to be sine, so 1/3 of sine, and then we need a plus c, and I know that u is 3x, but I also know that only c appears to have what I need. Okay, we've got antiderivative of e to the stuff over some stuff. In fact, that happens to be the same thing. That's interesting. I've mentioned that anytime something's in an exponent, that's going to be your u. So u is the square root of x. Du dx is going to be 1/2 square roots of x. You can rewrite this as power of a half and get to the same place. That means that dx is going to be 2 square roots of x du. Okay, plugging this stuff in. We've got e to the u. I'm not going to plug the u in on the bottom. And the reason for that is I want this to cancel out. So we get 2 square roots of x du. My square roots cancel out. That means that my antiderivative of e to the u times 2 should be e to the u times 2 still, and then plus c. We said that u was the square root of x. We're looking at a as our answer. For the next one up, we've got dy dx is 2y squared, and we've got some values to use. So let's do some separation of variables. So dy 1 over y squared is equal to 2dx. This is y to the negative 2, so the antiderivative of this would be negative 1 over y, because that would be y to the negative 1 divided by negative 1. And then we've got 2x plus c. I'm going to flip both sides because we have a 1 over y, and I want this to be y equals instead. And I'm going to negative both sides. So we get positive y over 1 is equal to negative 1 over 2x plus c. Now let's plug some stuff in. So we get negative 1 is equal to negative 1 over 2 times 1 is 2 plus c. That means that c equals negative 1. So then we have to rewrite this equation. Y is equal to negative 1 over 2x plus c, but plus c is going to be minus 1. Plugging in 2 now, so y is equal to negative 1 over 2 times 2 is 4, minus 1 is 3. I get negative 1/3 as the answer. And last up, we've got some areas and regions of things. We've got the lines x equals 0, x equals 2, y equals 0, and then a curve. I'm going to pretend I don't know what that looks like and just do a squiggle. I am just going to plug in some values. This should be 1, because if I plug in 0, I get e to the 0, which is 1. And then if I plug in 2, I get e to the 1, which is e. So just to make sure this is all positive. So if we're looking for area, that's going to be the antiderivative of going from 0 to 2. Those are my x values. E to the x over 2 dx. This is u substitution, where u is x over 2, therefore du dx is going to be a half. Dx is going to be 2 du. So we're going from 0 to 2 of 2e to the u du, which is going to give us 2e to the x over 2 at 2 and 0. Plugging 2 in, that's going to be 2e to the 1. And then plugging 0 in, that's going to be minus 2 more. And I don't see that directly there. No. Oh, that's the distributed version. Okay. So the other ones are good to go. All right, we've got the region, the first quadrant, bounded by the lovely graph of secant of x. Oh, good. I know secant sits on top of cosine, so we're looking at something like this. Pi over 4, secant of pi over 4 is going to be somewhere in there. And it's spun around the x-axis. So this thing is going to go this way. That means I've got to use this as a radius. I also know that the area formula for this is going to be pi r squared. No, they're not. They're round. I got you again, Kyle. So we know that we're taking a look going from 0 to pi over 4 of pi, and the radius is going to be this function. So secant of x squared. The good news here is that secant squared of x has an antiderivative that we can do pretty easily, because secant squared is the derivative of tangent. So we'd be looking at pi times tangent of x at pi over 4 and 0. At pi over 4, tangent is 1, so pi times 1, and then at 0, tangent is 0. So we get pi as our answer, which happens to be C. I got scared for a moment. I didn't see that, but then I just realized that I can't see. All right, that's all we wrote today.